Alright, gang, here we go. This is for Chem 1, Unit 12, Part 1. We're talking about general acid and base properties. Should be pretty fun. Alright, acids and bases, super common chemical reactions. Alright, pretty important stuff to understand. Alright, play a big part for the rest of the semester. All right, pretty much as usual. So acids are things that have these properties. Okay, they have sour taste. Okay, lemons, vinegar. So citric acid is what's the main acid in lemons, and that's what gives it that nice sour tart taste. Same as like orange juice and stuff like that. Vinegar is acetic acid. All right, they kind of taste sour. All right. They react with active metals to form hydrogen gas. We've done this reaction so many times this year. It's ridiculous because playing with hydrogen is a lot of fun because it burns and pops and sizzles and all that stuff. So anyway, so we've done this reaction quite a bit. All right. So hydrochloric acid. There's your acid. It reacts with zinc to form your hydrogen gas. All right. It changes the colors of indicators. Okay. So your litmus turns red, and phenolphthalein, it's clear. We'll have a whole video about indicators coming up here in a little bit, so you'll get a much better idea of how this works. All right. And they make electrolytic solution. We talked about this in the previous unit. Remember this, essentially what this means is that it has ions. Okay, so it makes these ions and hydronium ions for the electricity to flow through. Now, here's just a review on naming acids. We did this, oh man, it's been a couple of units now, naming our acids. So maybe it's time to review this stuff. All right, so remember, if your anion, that's your negative ion. If your anion ends in "ide," okay, so like chloride, Cl minus, then you add hydro, and then the stem of the name, and then ic acid. So like HCl would be hydro, and then your stem was chlor, and then you've got ic acid, so hydrochloric acid. If your anion ends in "ite," okay, like sulfite, you don't put anything in the front, so it's just the stem, and then so in this case it would be sulfur, and then you add us, and then acid, so this would be sulfurous acid. And then if it ends in "ate," remember you ate something icky, so your "ate," you keep your stem, so that would be the nit part of it, and so then it would be nite, and then you'd add the ic part, so nitric acid. All right, so there's your naming of those "ide," "ite," and "ate" molecules. All right, base properties. Bases are bitter. Okay, like soap. If you've ever cussed and your mom made you wash your mouth out, okay, that bitter, gross taste that you had was soap. All right, and so that's bitter. It's a base. All right, they feel slippery. All right, so you feel soap. Soap is a base. You can feel soap and it gets all slippery in your hands. Like if you're ever, in the lab, maybe sometime this year you've accidentally touched some of that sodium hydroxide we've had in about. You might have noticed that it was pretty dang slippery, more slippery than just regular water. But you got to watch out. It's very caustic. It can cause some damage. So it's not like you want to just like say you want to go down a slip and slide. Well, I'll rub some mace on myself. You don't want to do that. It'll hurt you. All right. It'll burn you. It's caustic. All right. They also change the colors of indicators. Now we just talked about what acid does to litmus and phenolphthalein. Bases do something slightly different. They turn litmus blue, and phenolphthalein turns pink. All right. And once again, we'll talk about indicators more in a couple of videos. And they also form electrolytic solutions. They'll conduct electricity. All right. Now, when acids and bases react together, they have an interesting reaction and they form a salt, okay, and water. Now, a salt, all right, is this thing that you do when you like pick up like a rock and throw it at somebody. No, I'm just it's the wrong kind of a salt. So you've got a salt, so we have table salt, and you might think, oh, it always makes salt, like sodium chloride, but that's not quite true. A salt is anytime you have a metal with a non-metal, okay? All right, metal with non-metal. All right. So if you're reacting, two things, and you're an acid and a base, you're always going to form a salt, that metal and the non-metal, and water. All right, salt and water. Okay, and so salt is the general term for ionic compound made from a neutralization reaction. All right, so if you look at these and you just think about your reactions that you're familiar, this guy should look like a double replacement reaction. That's essentially exactly what's happening. You got there's your cation and your anion, your cation and your anion. And they're just going to flip flop do-si-do, right? So your sodium and your chlorine are going to go together. Make sure your charges match. Sodium's +1 and chlorine's -1, so you get 1 and 1. And then the hydroxide's going to go with the hydrogen, right? And so you might be tempted to be like this, HOH, but this is not how we write water, right? HOH is the same thing as H2O. So we always write water like this, right? So there's your salt, your table salt like you're used to, and there's your water. All right, and we can do the same thing with the next one. We got hydrobromic acid reacting with potassium hydroxide, cation, anion, cation, anion. All right, so the cation and the anion are to go together. So there's your water, H2O, and then the cation and anion from the other one are going to go together. So you got your KBr. So your reaction produces water. There's your water part, and then potassium bromide, your potassium, or your ionic compound right there. All right, and so that's it for part 1. You made it through. Proud of you. This was a rough one to sit through. All right, anyway, so I'll do your practice problems, and I'll see you on the flip side.